Alrighty. Happy Tuesday again. You guys mind if I sit down? Is that alright? Instead of standing? I only lose like 2 inches of height because it's a nice tall chair. Does it work out okay? Alright, so we got a couple things today. Working on Chapter 5, Coding Methods. Methods are huge. We're adding to our toolkit of things we know how to do to solve problems. There's nothing you can't do with a method that you could do without. Right? So like we're not able to solve more problems because we know how methods work. What we're able to do is we're able to save time, save some pain of having to copy paste things or repeat ourselves, and it really helps us put names to what's happening. So we got a couple good benefits from methods in that they make the code a little easier to follow sometimes. Well, at least once you understand what a method is, it's easy enough to follow it. This handling exceptions and dealing with validating data, again, some helpful tools and tips and tricks we can use just to make everything be a little cleaner here. And I did find out, we had a nice faculty presentation from our manager of environmental health and safety. I have to take seating, like write down who sits where, if we're within 3 feet of each other, in case someone gets exposed. So as long as we're not within 3 feet of each other, we can sit anywhere and it will be fine, given the latest guidelines from our Department of Health and Human Services. So should be okay. I probably should have taken that. Yeah, I think that works out well. My dean sent me a PDF with 25 boxes on it. I was like, here's your seating chart to fill out. I'm like, you really had to send this to people? Like, but apparently people wanted the seating chart. So he's like, here's a PDF, hit print. I don't know. I think he was tired of dealing with people. So we're just adding to our toolkit ways that we can solve problems. Again, making things a little cleaner, a little nicer. One of the things the book likes to focus on is that it avoids repetition in our code, which, yes, that's definitely true. But I think a better reason to use methods as we look at them is it's going to put a name to what's happening. Right? Just like we use nice variable names so we know what the variable stands for, we should use nice method names so that we know what that method is doing. All right. Okay. Someone want a dad joke? Am I behind already? So I just got another good one here for you folks. I love these. Where do bad rainbows go? Prism. Yeah. Yeah, root guy, definitely easier to test. We haven't really gotten to the testing portion yet, but we'll get there. It's another benefit of methods for sure. All right, NetBeans, come on, cooperate. Oh, I think I can stop the music too, right? There we go. Still haven't figured out how to get sound out of my laptop yet. So maybe that's the next thing I have to figure out. It's got a volume knob, but nothing. Oh, is it because I'm muted?
Is the right run output or the...
That's a good question. Let's try it and see.
Because I've got 3 of mine.
Oh, it does work. I was just muted the whole time, so that was user error. Right, we don't need the music in class, but it's good to know. Good to know. Then we can play funny videos. We can all hear it. Oh, come on, that beats. So we've been working in a single method so far. All of our code has gone inside of that public static void main string square brace args thing. That's a method. So that's the first method, and that is where Java looks to start a program when you run a Java application. It's looking for that main method to know where to start. So we're going to go and do more methods. It's essentially going to let our code jump around. So it says, hey, I'm at this line, go somewhere over here, and then do this bunch of code. New project. Java Advanced, Java application. This is in 1500. This is methods. Awesome. Want a new laptop? It's only like 2 years old, but maybe 2.5 at this point. Close out some of these other projects. There we go. All right, and I'm just getting rid of some of this star comment stuff because we don't want it. So this public static void main string args is a method. Okay, we're going to write another method in just a second here, but let's say, hey, we wanted to ask the user for a number, and we'll print up to that number. So we'll say enter a number, I don't know, 1 to 10 maybe. And then if we need some input, we need our scanner keyboard, with a new scanner, given system.in. And then we'll get that number, right? So we have an int for number is integer.parseInt of the keyboard.nextLine. Grab their line of text, turn it into an integer, save it as number, and let's loop. We'll say for int, I don't know, n. N's not really great, but that's okay. And 0, n is less than number, n plus plus. N plus plus, there we go. We'll print n. We'll print the number. So we're going to count up from this number, right, up to whatever they give us. So they give us 1, we'll print 0. Because 1 is not less than 1. Again, depending on what you want. If you want to start at 1 and go equal to 1, sure. If you want to start at zeros, whatever we want to do for our loop here. I'm going to add our import for scanner, and let's make sure it works before we try anything else. So let's run. Oh, is it over here? There it is. Yep. All right, enter number 1 to 10, 5. We get 0, 1, 2, 3, 4. Right, so it's working as expected. It's giving us all the numbers up to here, not inclusive. That's okay. That's how we wrote it. Now, if we wanted to do this again, what options do we have? If I could copy paste it, essentially. I mean, it's not going to work quite exact because I don't need to make a new scanner. Sure. And yeah, we're going to do that in just a second. So we could modify a few things here and ask them again. Sure. Or we could put it in a loop. Right? This whole thing could be in a loop while, you know, a string for again equals y maybe. And while again equals ignore case. If it equals the letter y, then we want to keep on doing this whole thing over and over and over again. Sure, we could do a loop. That's a semicolon, not a no. Right, so this will keep us going again and again and again, but we should make sure we're asking them. Right, make sure we're changing again here. Right, and you want to run again and like tell them, hey, y, you know, yes or no, y/n. Hopefully they'll get the hint and enter a y, and then we can reassign again. Right, is the keyboard.nextLine. Sure, we can do all that. Right, and this will run many times as we want it to then. We can pick out a number, print it, pick out a number, print it, pick out a number, and print it. Not the most interesting piece of code here, right? But it works, right? The other thing we can do is we can write a method to do this. So a method is saying, hey, here is a bunch of code that I want to put a name to. And that's all it is. So everything so far has been inside of these curly braces of main. So now we're going to come outside of the main curly braces, but still inside this class curly brace here. And we can add new methods. So some people say leave main at the top. Some people don't care. I don't really care. I think main at the top makes most sense. So I'm going to go below main here. Now we need a couple special keywords. So public is what we're going to use for now until we get to the next chapter. So everything will be public. It doesn't technically have to be. It could also be private, but we could care less. So for now it's public. We'll say public. And then static, again, has a special meaning. Doesn't really mean a whole lot to us yet because we haven't gotten to the next chapter. So public static for everything, for now, right? Then we get a pick. There's a void option here. And void's the easy one. Void means I'm just going to do something and be done. I'm not going to return any values. Things like next line return a value. Right? When you call next line, it gives you back a string. So you know that's a value returning method. Void means I'm not going to return anything. Integer.parseInt. ParseInt is a method that returns an integer value. Right? We can take what it gives me back and assign it somewhere. Printline doesn't return anything. We call printline, print ln, and it spits something out on the screen and is done. So printline is a void method. So void just means it does something and stops. a returning type or a value returning method will give you something back that you can assign if you want. So for now, we'll do void. Void's the easy one. So void means we're not going to return any values here. Then we get to pick a name for it. Same as the rest of our programmer assigned names, all of our variable names. You want something nice and meaningful. Starts with a lowercase. Every next word gets an uppercase, whatever we want to do here. So we'll call this one print numbers up to n. Sure. So public static, if we want to return something or not, void or a type, and then the name of it. Then it gets its own set of curly braces. So anything inside of this set of curly braces, sorry, I can scroll it up, will run when we ask this method to run. Sure. So if we want to print the numbers up to n, let's take all the things we're doing here. And I think just here, right? I'm going to cut that and put it in here. Give it a quick little format. All right, so it doesn't know what a keyboard is. We need another scanner. So we need scanner keyboard equals new scanner in system.in. All right, so they both look pretty happy now, but we haven't actually done this one yet. Right, there's nothing, we took it out of the while loop. So to ask this method to run, we just call it by name. So we'll say print numbers up to n. Sorry, format that. So when it gets to this line, it's going to jump down to line 17 and say, oh, okay, let's do everything inside of that set of curly braces, and then I'll come back to here when I'm done. So we're still doing this whole again thing, sure, because we want to run it over and over and over again, but now we at least have kind of a name to what's happening here. Right, so if we put this, I'm going to put a breakpoint. We'll start it here at 8, and we're going to run this in debug mode and watch it go line by line by line by line. This is really fun, and using the debugger is great. All right, so we're here at line 8, ready to run. That's the green arrow. This is the line we're currently on. Oh, this is better, actually, and this is down below. Let me bring it down here. Okay, so now I can see all the variables. It's small on my screen, I apologize. There was a way I thought I could zoom it, but it didn't work for me. I have to try it again. But we're going to go, so there's a step over. Sorry, sugar is not cooperating right now. It keeps warning me. That's what I get for eating Chinese food for dinner. It's like, it's a big carb bomb. Everything's so sweet with all the sauces. Delicious, but sweet. You think it's just chicken, but like it's the breading and the sweet sauces and everything. So many carbs. All right. So remember, usually we're going to step over. We're also now going to use this step into in a minute. So the over will just go down to the next line, but over will also skip our methods. Right? We need to step into a method. We'll see that in a second. So we assign again, and now we can see again has a value of y, real small, sorry, up on the screen. We create the scanner. Now there's a scanner object. I'm calling it keyboard. Sure, ready to go. We're going to check the while loop. All right, now we're at line 11, ready to run. So I want to step into here to make sure I go into my method. And we get, okay, now we're at line 18. So over here on the left-hand side, this kind of top left here, you'll see Java remembers where it was. It says, hey, I was at methods line 11. Now I'm at this methods, that's the name of our class here, line 18. So when it's done with this, it's going to come back to line 11, right where it left off, so it can keep on going. So every time you call a method, it's tracking where it was before that, so it can come back to where it was before. Now, this is referred to as the call stack. That's our technical term for it here. And you might have heard when we look at those errors that spit out, the big anytime it crashes, I say it's a stack trace. That's a trace of what's in the stack here, this call stack. And it's telling you all these different things that happen. So we only see the stuff in main, but there's a whole bunch of other nonsense that happens behind the scenes. All right, so we're at line 18 here. We're just going to step, and now it's waiting for us, right? It's waiting for this keyboard next line, so we'll give it a number. Open this output tab. Should be output, right? Oh, right here. Methods, not the debugger console. So let's give it 5. And it's waiting to go. And we can step for each of these if we want to watch the loop happen. Sure. We can see n changing every time, which is nice. Stopped. Now we got to the end of this method. So we're at line 26, right? That's the curly brace that matches this one here. Right? We can tell visually, if we do things right, or we use the auto formatter, that it's at the same indentation level. That's our visual clue, that that's where that ends. If they don't line up right, just hit auto format. Go to your source and hit format. It'll align everything for you. You don't need to do this by hand, right? So all that visual clue, this is stuff programmers are used to. That's how we read our code. Now when we step, you'll see it's going to come off the call stack. And we're right back to where we were. We were at line 11. It's finished. Now we're at line 12. Ready to run again. And it's going to wait again. We'll figure out if we want to run again. We'll say no. The while loop stops. Program's done. So we can watch as it jumps to these methods. So it's essentially a jump. It says, hey, go to here. So we've put a nice name to what's happening. Now, the cool thing is if we want to do it again, right, we can just put it in here, and maybe we run it twice. I can call the method a second time, and this is not a very good example, because why would we just do it twice in a row? But the same method can be used in more than one location. So instead of having to copy-paste all this code, like we looked at like the first time if I wanted to do it twice, I could just call the method twice if I wanted. And we got lots of fun options. Okay, so that's our basic void method. Nothing super interesting here. Let's do another method, another little helper method here, because this integer.parseInt is kind of obnoxious, and it's a lot of things to type. So let's write our own method here. So we'll do a public static. Now we want to return a value. So this, instead of saying void, I'm going to say int. I'm going to say, hey, Java, I'm going to give you back an int when this thing is done. So the last thing a method does is it can return a value. So this is an integer type here, and we'll ask the user for an int. Okay? So we'll take enter a number, take the scanner, grab all this. I'm going to cut it out here, put it in here. And then the keyword to give a value back is return. We say return number. So if I return this number, I'm going to give you back the variable. So up in my code up here then, if I want to use this method, I want to save it somewhere. So I want to save that number. So I'm going to say int number is equal to ask the user for an int. Notice these all have parentheses. Method calls always will have the parentheses here. So it's not, I can't just say ask the user for an int semicolon. It doesn't know what that is, but ask the user for an int parentheses, it knows what that is, because a method will have the parentheses. Like next line has a set of parentheses. That was a method call, right? Sometimes you can put things in parentheses. We'll get to that in just a minute. We'll look at some of those other types of methods. So I can get an integer out now. Sure. Now this is all well and good, but it's only going to ask me 1 to 10. But sure, that's fine. So if I run this in debug mode again, let me put my breakpoint back, run it in debug mode. We're going to see it goes to this method, adds it to the call stack, goes to the next method, adds it to the call stack. There is an upper limit, but for our purposes, we're never going to hit it. So don't worry. Like you could call 50 different methods. A method could call a method, could call a method, could call a method, could call a method, on, and we're not going to hit that limit. Sure, that's no problem. There's, I think it's like 1,000. I forget exactly what it is. I don't have the number in my head. We could Google it, I'm sure. So I'm going to step in. Now I'm at my print numbers method. I'm going to step in again, and I'm at my ask the user for an int method. We'll see in the call stack, again, sorry, it's kind of tiny. I'm at line 26. When that's done, I'll come back to line 18. When that's done, I'll come back to line 11. And it should do exactly the same thing that we did every time. Enter number 5. Step. It returns the number. So now we're going to see number has a value. Now number is 5. And it's going to do our loop, sure. Print out number a bunch of times. That method's done. All right, we come back to, all right, do we want to do this again? Yes or no? Waiting to get that next line. We'll come back to our output, and let's say no. We're all done. The while loop stops, and the program's done. Again, we're just putting a nice name to it. We haven't really gained anything. We're not going to reuse this code, at least in this example, more often than one time, but we kind of have a nice name for what's happening here. Okay. Now we can do even more, right? So we probably start, again with the Y. That's fine. And then let's get rid of this one here, and then we'll figure out whether or not we want to ask the user if they want to do it. So I'm going to add another method in here. So I don't know, it doesn't really matter, top, bottom. Some people like to do them in alphabetical order. I don't I mean, whatever floats your boat. So this time we're going to return a string. And we're going to call this ask the user if they want to run again. Again, right? So two things, it needs scanner. Now, notice every time I have to add scanner, we briefly talked about when we looked at like if and while and all these other loops, if you define something inside a set of curly braces, you can only use it inside that set of curly braces. Same thing works for methods. So when I had that keyboard scanner keyboard up here in main, it only existed inside of the main curly braces. Yeah.
So if you put the scanner outside of that curly braces and put it at the top, so it becomes the whole thing, and you don't have to add it again and again and again?
Yes, yep, that's the next thing I was about to show. Thank you. Yep, so every method that wants to use scanner has to define a scanner, or we can make something called a class level variable, so it exists for all methods inside the class, right? We have this class curly brace here that we haven't really talked about and touched. You can define the scanner up here. Now the trick to that is you have to tell it that it's static, which is fine. We've been using this static keyword a lot here. Again, you can use public or private. Generally, when it comes to class variables, private is preferred. Like these methods are being public, sure. We're not going to worry too much about it, so if you put public static, I'm not going to care. Next chapter, we'll talk about better practices. But that's fine for now. So we can say public static scanner, we'll call it keyboard, equals a new scanner, given system.in. So this is defined and instantiated at the class level. So it's only at the class level curly braces. So anything that's inside of these curly braces, anything lower, like within these set of curly braces, can see this variable called keyboard. So now I don't need to redefine it every single time. I can just use it in all my methods. Now we just need to tell it this was a string, and then we'll return again. So notice before I had that return line, it gave me this nice red error here. It says missing return statement. Because it knows I told it it's going to return a string, it won't compile without a return some kind of string. Now I could say return like an empty string. It's perfectly fine because I'm returning a type of string. I've done what I've said I would. I would return a string. Doesn't mean I'm returning the right one. But so just because it compiles doesn't mean it's going to do the right thing here. So we're going to return again. Okay, so we ask the user if they want to run again. Sure, we'll do this up here. We'll print numbers and we'll say again equals asks the user if they want to run again, semicolon. So we've gone from everything being in main to like almost nothing being in main now. So we have our loop. Sure, it will print the numbers up to n and it will ask the user if they want to run again. So without actually even seeing the rest of the methods, if this was the only bit of code you saw in my program, you kind of have an idea of what it's going to do, right? Just because of the names. That's the big benefit, right? If we name our methods well, just at a glance, you can kind of get a gist of what's going to happen. So a nice goal to have is to limit the amount of code you have in a main method, right? It's a nice goal. It's not a hard and fast rule. Like no one's going to yell at you if you don't. But if we can put things in methods with names, it makes it easier just to look real fast at the code and say, oh, okay, I think I know what's happening here. That's all. So ideally, we have most of our code in methods that we call, and those methods can call other methods, sure, or not. And any way we want to go about that. All right, so we're defining our own methods, again, inside the set of class curly braces here. So these are class level variables. So a class level, right, is defined at the class level, not inside of a method. If it's defined inside of a method, it's at the method level, essentially, or scope is our technical term for that. So the scope determines where it can be seen, where it can be used. And now, just because it's declared at the class level, you can do silly things and redeclare it at a different scope. So if I wanted to, inside of main, I could do this again here, and it's only going to warn me that, hey, it hides a field and it's never used. It's not going to stop me from doing it. So it's legal code, it's just dumb code, right, to try and do this again. That's all. So this is usable in all methods in the class now. Again, we're just going to put public static on pretty much everything for now. Next chapter we'll get into some better practices, but we don't have to worry about it tonight. So our methods are public static, and then void if they don't return something, or the type that they return. So you can only return a single type. So if I say int, I can't return a string. If I say int, I can't return a double. Right? If I say int, I can't return a scanner. A scanner is a type. If you really cared to, you could return a type of scanner. You can do all sorts of, any type in Java, anything in Java that you want, you can say, I will turn this type, and it's going to work. All right, how we doing? Looks like internet's stable. That's good. People got quiet on chat, so I was worried. So we got a couple methods here. Now, the next cool thing you can do with methods is, it's only so useful, like for this, ask them for a number if we only say 1 to 10. Right? So what we could do is, instead, we can say, hey, if you want to call this method, you need to give me something. And I'm going to use that value. So inside the set of parentheses here, we can list, these are called arguments or parameters. Technically, it's a parameter this is called the method header. And when you call it, like when we're calling print line, it's an argument. I don't understand why people care about the difference, right? I think they're essentially interchangeable. But if people want to get particular, this is an argument here. And when you declare one, it's a parameter. Sure. So we can say, okay, what's the string for prompt? So if you want to call the ask user for an int, you need to give me a prompt here. What this does is, this now is a variable of type string. So I'll say, hey, you need to give me a string. I'm going to call it prompt inside my method. So everywhere inside the method, I now have access to this thing called prompt. And it's whatever they gave me when they called the method. So I can print, instead of, hey, enter number 1 to 10, I can print the prompt. Whatever prompt they give me, I'm just going to spit right out to the screen. And then I'll grab the next line of keyboard input, turn it into an integer, and return that value. So now it's red here, and it says, method asks the user for an int in class method cannot be applied to given types. Required string, found, no arguments. So empty parentheses means there were no arguments given. If I want to call the method, I have to give it a value. Like integer.parseInt, when we do that, you need to give it a value. If I just say integer.parseInt, parseInt, and I don't give it anything, it's going to be upset with me. Same thing. This is no suitable method found for parseInt, no arguments. Error is ever so slightly different, but the same idea. You don't have the right argument. We're missing an argument here. So I need to give it. Well, what's the prompt? We'll say enter a number 1 to 10. So now I'm going to tell it, hey, here's the string that you're going to go spit out asking the user for a number. Doesn't seem like we've gained anything yet, but now if we wanted to do this again, right? Say if they do want to do it again, that's fine. In a different place, we could say like 1 to 100. We could change it here, or in a different method, ask them 1 to 10 in this one, in a different method 1 to 100, and another method 1 to 1,000,000. And we can change it when we ask for the method to be run, instead of the method only doing the one thing. So now we're flexible. So this is very useful if you're doing a similar bit of code, and the only thing different is that, like, the value you're operating on. So if we keep doing the same thing over and over and over again, but the only thing that's different is, hey, what we're asking for with this prompt here, great. Or if we're doing some sort of arithmetic, if the arithmetic we're doing is always the same, we're just asking for different values, we can make them arguments or parameters so they can change. So we can do some math, right? Let's do public static. This will be, what, a double value? Let's do, I don't know, number squared, int number. And we can return number times number. Right? A single line is okay. You don't have to say like int result equals number times number, return result. You can just return your arithmetic if you want. Right? So the same idea as like saying int result is number times number, and the return result. Right now it's yelling at me because it says you can never get here. As soon as a return line is hit, the method stops. So, like, just illustrating, this is the same thing. You don't have to have the step to save the value and then return it. You can do your arithmetic right in the return. Because everything evaluates, it does the thing, and then I'm going to return. Right, kind of like our order of operations. When you assign something, it does the arithmetic on the right, and then it assigns, or it does arithmetic and then it returns. That's all happening in that same order. So our number squared, we can square any number we want now. I can give it 7. I can give it 1,000. A million won't work, right? Because we don't have integers large enough for that. But, that's okay. We're not too concerned. Oh, no, it's a double. Yeah, we could do a million squared, right? Because doubles can be even bigger. Sure. Maybe this should be like a long. Remember, longs are really big integers. We're not really going to use them. So, or just say int. I don't know. Why not? For our purposes, we're fine. So your method can have an argument if that's the thing that changes. So we're always doing the same arithmetic every time. That's how that math library works. Remember when we said math, with all the math operations? Math dot, you got to, like absolute value. Any double that you give it, we can do the absolute value of. It's the same arithmetic. If it's less than 0, multiply by -1. If it's already greater than 0, you're done, right? So over here in this library, it tells us this is the return type. This is what we can expect to get back from the method. So if you give it a double as an argument, it will give you back a double return. Right, a bunch of things. Power, right? A number to a power will give us back a double, sure. Random doesn't need any arguments, but it gives us back a double. And that's the number between 0 and 1, but not including 1. Random's obnoxious sometimes. So you can see all those methods are built into the Java library in math. We can do all the mathing. So we could write our own methods if we want. Again, squared is kind of silly, but sure, why not? Right? We can if we want to. All right, so we got prompts. We got ask the user for an int. Cool. Yeah, so we put some nice names to things. If you want more than one argument, you can do more than one argument. You can just comma separate your arguments here. So let's do some more. Let's do public static. Let's. What do we want to do? Yeah, we'll return a double, and let's do. What's some fun math? Let's find the, oh geez. For simple ones we could. Let's say first root. Right? It's not a root. What's when you do the quadratic formula and you're finding that it's the first X-intercept. Let's do that. Intercept. Right? If you are given a quadratic equation, like something x squared plus something x plus something, right? Or ax squared plus bx plus c, we can find where it intercepts the x-axis, if there is one. Right? Usually you'll get both with that lovely formula. If the math doesn't make any sense, that's okay. It wasn't a requirement or anything, but it's fun. So we need those values. We need a double for the a, we need a double for the b, and we need a double for c. Now, a, b, and c are terrible variable names, but that's literally the math equation. It's ax squared plus bx plus c. Like, I'm not feeling too bad about it being a, b, and c, because that's usually what it is here. Okay, and now the problem is you can only return a single value. So I can't give you both intercepts. Usually there's two. Sometimes it's the same value, and sometimes it doesn't exist, thanks to math. You can blame math for that, but we're going to attempt to find the first one, and we'll see if we get lucky. Right? So to find it, right, we had x equals negative b plus or minus the square root of b squared minus 4ac. That's terrible notation. That's not going to work in Java, but I just want to try and get that out here, right? So what our potential value is. So double, we'll try first x-intercept. Or no, it's the y-intercept. It's the x value that intercepts y. And it has been a while since I took a math class. And you guys are not checking me on this? It's all right. So it's negative b. So we can do negative b. It's a plus or a minus. So let's do the plus one first. And then we need the square root. So math dot square root of, we need b squared. So b times b, probably the easiest, right? Minus 4 times a times c. Oh, both divided by, that's right, 2a. right? All over 2a is the whole thing. So I should put in some more parentheses here, right? Make sure we do that right. So if we want all of that, then divided by something, we'll force our order of operations, divided by 2 times a. Now, this is not going to work, right? Because it's going to divide by 2 and then multiply by a. That's bad. So make sure you, again, order of operations, your 2a here. Does this ring any bells? It's college algebra? Right. It's okay. It's been a while. It's okay. So I think we've got everything happening, right? This is b squared minus 4ac. The multiplication will happen first, and then the subtraction. Great. Divided by 2a, the whole thing. Awesome. That'll attempt to find the first one here. So this is just our comment here. And then we can return that value. Return first y-intercept. So technically the second one, right, is the same thing. Second y-intercept is the same arithmetic, but minus. Because we did one as a plus, one as a minus. We can only return a single value, so we're a little sad that we can't return both. We'll get to that later. There's ways to do it, but we don't really care right now. And return the first one. Now this is going to crash if this value is negative. Right? You can't take the square root of a negative number. So it's really possible you don't find any of these values. Okay, that's fine. We'll just crash here. So we'll just say it's okay. It crashes if there isn't an intercept. We'll feel bad about it, but we'll learn a little bit later what we could do instead. Okay? So this needs a couple arguments, right? So we just comma separate our arguments. All of this to say, hey, I can give it 3 different values. I can give it 5 different values. 10. There's a limit somewhere. I forget how many values it is. For all intents and purposes, we don't care, right? So let's try it. So to do that, then we need to ask them for a couple numbers, right? So we could prompt for a couple numbers, ask the user for an int a couple times. Sure, so let's do that. How about after here? So we'll print, let's solve a quadratic for you. So the first was an a. Right, so we need a double for a is prompt the user for an int. Or ask the user for an int? What do I call it? Ask the user for an int. Why wasn't that coming up? Ask the user for an int. There we go. Enter the a value. Okay, we'll get an a value. And again, these are integers. It's fine. They could be decimals, but we already have integer. That's fine. We don't really need to redo this as a double. A double for b. Same thing. Ask them for the b value. And again, ask them for a c value. The c value. And then we can get a result. So we can say, here's our double first intercept is, and what do we call that method here? We said first y-intercept given a, b, and c. Cool, and let's print it out. The first intercept is first intercept. And maybe y. Maybe we'll call that y-intercept. Nope, sorry, plus. Plus to concatenate that in there. Right, let's try it. So it's if you haven't seen Desmos yet, this website's awesome. It does math things for you. You want the graphing calculator. It's super cool. So we can give it like y equals 2x squared minus 3x plus 7. Let's go like minus 7. There we go. Sure. I just picked some numbers. So it's going to intercept here at 2.766 for an x and at negative 1.266. We're only going to get one of those, and we're probably going to get the positive, right, because we're adding first. And again, that's fine. So we can see in our graph, again, the math part doesn't actually matter. It may or may not be interesting if you're taking a math class. We should get this first value back out. If we give it 2, 3, and negative, I'm sorry, 2, negative 3, and negative 7. Right? So this is really negative 3 here. It's not really a minus, it's plus negative 3. Otherwise, the math doesn't work out right. So enter a number, sure, run again, no. All right, A, we said was 2, negative 3, and negative 7. 2.765, 2.766. It looks like it rounded for us, right? Thanks. So we're even more precise than the fancy graphing tool online is. Not that many digits of precision really matter at this point for us. But I guess if you're building something like a building, you probably care. But I don't know. Did we spend the time Googling how far you can get, like, past Mars with like 15 digits of pi? Oh, it's so good. It's so good. How many bits of pi do you need to land on the moon? This was an article someone put out from the Jet Propulsion Lab at NASA. So if you use 15 digits here, you can get within, what do they say, 12.5 billion miles away and only be off by 1.5 inches with only 15 decimal places. I mean, I guess it's a lot of decimal places, but it also doesn't feel like a lot to be 12 billion miles away. So, yeah, we're pretty good when we do arithmetic with doubles. That's just a fun aside. Right, so that one seemed to work. Okay. Again, it's going to crash if we give it bad values. Like, we do no. But if it was 2, -3, and then +7, NaN doesn't actually crash. That's kind of impressive. This is short for not a number. If you try and do bad things with doubles, you get not a number results. We tried to, pretty sure in here, where did that go? This square root was a negative value. Right, 3 squared minus 4 times 2 times 7. Right, we got a negative, so square root of a negative number is going to fail. It's not a number. Sure. No real results. At least it didn't crash. That's kind of happy. All right, so we can make methods with multiple arguments. You just comma separate, or multiple parameters. And when you call it, you have to give it all those arguments. So we've been doing methods all along. Like printline was a method. You had to give it an argument. We just didn't really specify. We didn't have the words for what this all was. Right? Integer.parseInt needed an argument. It needed a string to try and turn into an integer. Right? Next line was a method. It didn't need any arguments. So again, this was, maybe this should have all happened in this same find the y-intercept. I don't know. We could have put all this separately where it asks you for it, but it's nice that this is just the math rather than ask you and then do the math, right? If we wanted to just do something silly and like, hey, let's do a loop inside of a loop inside of a loop for like 10 values of A, 10 values of B, 10 values of C, let's find all of the intercepts. We could do that in a loop if this method just takes these arguments. If the method also asked for inputs, it'd take us a whole lot longer. So generally it's nice, right, to separate out, here's the thing that I'm doing and here's the input that I'm doing. Just kind of depends on what you're aiming for, though. So it's easy to repeat the operation than it is to repeat the prompt. And as Root Guy had mentioned online, it's easier to test if the only thing it does is does the operation. I can give it some values and get back out what I was checking for. Really easy. And I can give it a couple different values if I wanted. Yeah. Cool. I think we're at a pretty good place. Here, let's see. Static methods, arguments. Yep. Ooh, this one's fun. So you'll notice we had this string args thing up here. This is actually an argument provided to the main method. So when Java runs, you can give it arguments when the program starts for it to have. So how many people do you know sit down at their computer, start a console-based application, and start typing into that ugly black screen, kind of like what we have here? Okay. Your dad, yeah. I mean, they still exist, but most of our programs don't run like that anymore nowadays. Yeah. Yeah. So if we have a process that's going to go and do something, it'd be nice if we could like feed it some values automatically. So you can pass arguments into your program before it runs to operate on. You can do lots of fun things with this. Once we start talking about files, we'll do more with this, where you can pass it, hey, here's a file name. And instead of outputting everything to the screen, we can write everything to a file that then is going to be like persistent on our computer we can open up later. And you can do all sorts of fun stuff with that. Or say like if your program was a cash register, you're probably writing all of your data out somewhere because you don't want to keep it in memory in case that register turns off. Someone's going to be really upset with you if you don't know how much is supposed to be in there. Right? When anytime you deal with money, people seem to get upset if you screw it up. I don't know why. I think there was a movie about that. Are you any of you old enough to remember Office Space? All right, one. Okay, two. It's like a classic movie now, which makes me a little sad that it's that old to be classic. But sure, they were going to steal like the fractional pennies in transactions from banks, and then they screwed it up and sold whole pennies. And I won't spoil the movie, but other stuff happens. All right, so why don't we take a break here? We're going to switch gears and look more at some validation after and ways we can use methods to do validation and handle some exceptions so our programs don't crash so often. So why don't we take 10? I'm going to go grab some Coke. I've got a couple extra bottles if anyone likes cherry vanilla, Diet Coke Zero. Just let me know, and we'll go from there. Let's see, break time. 10 minutes puts us at what, 7:07? No, 7:04. I can't do math. 7:04. Alrighty, I think we're in good shape here. So we're going to look at how we can avoid crashing if someone gives us something that's not a number when we ask for a number. Right? I don't know if it's happened to you when you go and try and run your program and you're not really paying attention and you type in text instead of a number and it crashes. That's no fun. And let's just be honest, if your program crashes, it's like really frustrating, and then you don't think that program is very good anymore. So when you write actual code that people are going to use, and if it crashes on them, they're going to think your app sucks and start giving you bad reviews in the App Store or whatever, you know, however you've released your software, or just in general hate it. Even like if they're forced to use it in some sort of enterprise environment, it just becomes the butt of all jokes that that's terrible software that crashes. And for me personally, like, it's extra frustrating because I know it shouldn't do that. And it probably happened because they were lazy and rushed their software out the door, which is just another affront to good software engineering principles. So I like get double upset when things crash on me. So if we can avoid that, that's even better. So to do that, we're going to add some new special handling here. So anywhere we're dealing with user input. So we did, actually, I think only one place, right? We asked for an int, just in this one method, which is nice so that all of this extra stuff we have to do can be kind of put on its own side over here in this method and live over here and not make the rest of our code, I don't know, just, it's not even ugly, but not really have to take up any space. So it's always going to happen in this one place. So that's the great thing about using a method as well. And once you write the method that like asks for an input, an int input, and sure, here's the prompt, you can just copy paste it into every other project you ever do that you need validation for, right? Sure. So just grab this whole method once we finish it, copy paste it into every project you do. Perfect. So what has to happen is when it goes to crash. So let's run this again, and we'll get to when it asks me for a number. I'll put in 5 in text, and it crashes. So this is that stack trace. So it was at main line 14. It was at print numbers up to end line 30. It was at ask the user for an int line 40. And then, hey, there's some other stuff happening. This is the Java library code, right? Java.lang is the library code. Eventually, we got this number format exception. So this is the particular error, and you can have all sorts of cool, very specific named exceptions that are nice and helpful that we need to deal with. So if we get a number format exception, we want to not crash. So to do that, if you know something might crash in Java, we use a special keyword called try. And try says, hey, I'm going to do something that might crash, but let me try it anyway. And then to deal with that exception, we say catch. And what do we want to catch? Well, we want to catch a number format exception. I'm going to call it EX here. So the type of exception, and then what we're calling it, and then another set of curly braces. So anything that could crash goes inside try, and what you want to do about it if it does crash goes into catch. So the analogy they use is you throw an exception, and you can either catch it or you can crash. If you don't catch it, you're going to crash. So the idea is we're going to catch this exception that's been thrown so that we don't crash. So you say, okay, try this thing. If it doesn't work, what do I want to do? Okay, well, let's tell them, that's not a number, or an integer, right? Integer. Please try again. But we're not repeating this though, right? If we want them to try again, we need it to run again, right? So this needs to be in some sort of loop here. So we'll put this in a loop. Now, 2 schools of thought on this. I'm going to show you the ugly way first because it's faster, I suppose. You say while true. Sounds really dumb, right? Like, hey, I just made myself an infinite loop. While true. It's infinite. But then what you do is after this thing happens, so if it crashes, it stops at this line, no other code runs, it goes right to catch. So if there's another line of code down here, like break, this will never run unless this is successful. If this throws an exception, it's going to go right to the catch, it's going to skip over the break. Right? Remember, break is that keyword that will kill a loop. I don't like it, I think it's ugly, but it's quick and dirty. It gets the job done, so there's no shame, right? Now, it's upset though, and it says, hey, can't find symbol number. We declared this value number inside of the try block. It only exists inside the try block. So I need to declare the value outside the try block. Then inside the try block, give it a value. Actually, I think I can just declare, right? Yeah, we give it just a declare. I don't even need to give it a default value. Just, hey, I need a place to hold a number, and then it exists at this scope inside the method. So everything else inside can access it. If we declare it inside the try block, the scope is just to that try block, and it doesn't exist outside, we can't return it. The other thing you can do, which is slightly less ugly, so I'm going to comment this one out here, is right inside the try, you can say return number. The return doesn't need to be the last statement. It can be anywhere. Sometimes we consider that bad form because why is there a bunch of other code that, you know, I return and then other stuff could happen? But like we can read it, it just takes you another second or two or three to be like, oh wait, something else has to happen here. So I don't like this method either. I think returning inside is kind of ugly, but sure. So that way you don't have to break the loop. You feel better about not using a break, but now your return's kind of in the middle of your code and it's a little funny. So sure, again, I prefer it down below. That's just my preference. Was it red? On reach. Oh, I lost my break. Notice it was red here. If I have an infinite loop that it knows is an infinite loop because it says while true, it says you can't ever get here, dummy. This while loop will never stop. Now it's not going to tell you the while loop will never stop. It's not quite that smart, but it knows, hey, you have an infinite loop here. You're never getting out of that. So until it sees that break keyword, the compiler or our IDE is actually going to give us that warning, which is really nice. So it keeps you from doing bad things. Okay. Now again, this was the quick and dirty way. I'm not fond of it, so I prefer, and it's like an extra step, but it's just a preference for me. Instead of break, we put a Boolean here, like, what do we want to say? Try again, and we'll say true. And then we loop while try again is true. Instead of saying break here, then we can set that flag, that Boolean, it's like a flag, it's on or off, would say, hey, try again, equals false. The next time we go to evaluate the loop, we're good to go. Now, this is not quite as smart because now I'm checking a value here and the IDE doesn't know for sure that this is really going to happen. It can detect a break to know it will stop. It can't detect this quite as well, so it tells me, hey, it might have never been initialized. It says, I said I want one of these, but it can't guarantee when it looks at it that this actually got assigned. Sure, so you can say like number equals 0. Again, we know it'll get a value, but before the compiler didn't. So sure. So again, this is, you know, maybe one extra step. We have to have this Boolean here, but I prefer this method to break just because I think breaks are ugly. It literally does the exact same thing, but I think breaks are ugly. Returns in the middle, maybe not so bad. Probably better than a break, but still a little bit ugly. Like I like returns at the bottom, but again, totally up to you. It's not necessarily one right way. So now, if what we didn't do though, this prompt needs to go inside. Sorry, our prompt should be probably not. Doesn't need to be inside the try block per se. It could. It doesn't really matter if it is or not. But let's put it here inside the loop so that we're going to give them that same prompt after we tell them that's not a number. So run this again. And now when I ask for a number, if I say 10, it says that's not an integer, try again. 10, now it works. So this is called exception handling. We're handling the exception. We know something bad might happen, so I'm going to try, and I'm going to catch. So this is a nice way of making sure we don't crash if we get some really funky input. Our intercept calculation didn't actually crash. We got lucky. If it did crash, we could have did a try catch here as well, and maybe just return 0. 0 is kind of funny though, so maybe it's best that it actually gives you that not a number result thing, but that's kind of fun. So when you are using scanner, again, and I don't recommend it, but scanner has like that next int or next double method instead of just next line. Their exceptions are input mismatch exceptions. They're not number format exceptions, and I have no idea why. I think it's the same thing. Yes, we haven't really talked about that yet. So if you just want to catch anything and everything that could happen, You just say exception. You don't have to give it the specific one for reasons that we haven't got to yet. All other exceptions are a kind of exception, so this will work, but generally being more specific is better anyway. So more specific is the preferred method. Yep. All right, so we can handle our exceptions. Yep. So scanner, if you don't like this try-catch stuff, has some additional handling to say, hey, is there a next value? Which is kind of cool. You can like use has next double or has next integer, and that's either true or false. So if the number it's about to read is an integer or a double, you get true and you can go read it. If not, you can be inside some sort of loop and prompt them again. Sure. Again, I prefer not to use those because it leaves the enter key on the scanner to be read the next time you want a next line, which is really obnoxious if you're mixing and matching. So just next line is generally easier, and we just do this try and catch handling here, which is really cool. Let's see. Null pointer, I don't think we run in any of those. Shouldn't have, at least. Numbers, ranges, sure. Sure. Yeah, I think we're doing pretty good so far. So other fun things we can do, right? Where this prompt here, when we ask them for an int, is just a singular prompt. We're not doing any sort of validating on the actual number they gave us, right? Because our for loop here that we eventually use when we print a number, where'd it go here, right? We're saying, hey, plus plus, as long as it's less than the number. They could give us a really, really big negative number, or any negative number. No, I know. And yeah, n is less than, no, it won't be less than. I guess it could give us a negative number, just won't run at all. And that might be a little bit sad. So maybe we want to make sure it's not a negative value. Like we said, hey, 1 to 10, we should check for it. And we looked at how to do those validation loops. Well, to do that with a method, right, we need some additional piece of information. We need some additional arguments here. So we can write a method. This is public static. It's going to return an int, right? This is ask user for int within range. And then we'll have a string for the prompt. We'll have, I'm just going to go down a line so it fits on the same screen. We'll have an int for lower bound and an int for upper bound. So if you give me the string you want to use for the prompt, an integer lower bound and an integer upper bound, I can do the validation loop to make sure it's within that range that you asked for, all in one method here. Okay, so we need to, again, we're probably going to do this try-catch thing, which is nice. Ask the user for an int. Now, I already have this ready to go, so all I need to do is the bounds checking. Right? One method can call another method. So it already is going to do the prompt. Great. So what we need to do is check as long as we're not within the bounds. So I'm going to start off an int. We'll just say value, I guess. I'm going to start off something that is invalid. How about lower bound -1? I don't know what the lower bound is. They might have said -20 is possible, so I don't want to start at 0 or -1 because I have no idea, right? If the lower bound is the absolute minimum integer, we've probably done a bad thing. But the odds of that happening are probably pretty low. We could check for it in a little bit. So let's add, I'm going to add a note to do check for int minimum. Because we can be nice and smart about it. So I'm going to say while the value is less than the lower bound, or the value is greater than the upper bound. Right? If you are too low or too high, and we're going to OR these together, if either one of these is true, you need to stay inside the loop. Our starting value is less than that, so it should run at least once. Again, if you want to do a do loop, go for it, but I hate do loops because of the semicolon, because I'm weird. So while. So we'll ask the user for the value. Ask the user for an int. We'll say value equals, ask the user for an int, given the same prompt that I was given. So I'm going to take the prompt you gave me, I'm going to just keep on passing it. Say, hey, other method, have this string. Here's the prompt. I don't know what it is, but sure, here's the prompt. We'll get the value, And it already does all that try catch stuff. I don't need to repeat any of this because we already did it once. Right? That's the other beautiful thing about methods is once you've done it once, you don't need to do it again. Right? We've already done this cool try catch stuff. Why would I repeat it in another method? And if the value is less than the lower bound or greater than the upper bound, it's going to run again. If it's too low or too high, it's going to run again. Too low or too high, going to run again. As soon as it is not less than the lower, false, and it's not greater than the upper, false. False or false, they both have to be false for the whole thing to be false, the while loop will stop. Then I can return the value. Okay, so we haven't checked for minimums yet, though. So we could do that. We could check for this. We could be a little bit smarter here. So we can do this first. We'll say if the lower bound is equal to integer.minimum value, min value. If that's the absolute lowest you can go, there essentially is no lower bound, right? Any integer up to negative 2 billion is fine. This loop needs to be different then. So then our loop then is just, hey, as long as we are greater than the upper bound, keep on asking them. So really, then we can start value at upper bound plus 1, maybe. Upper bound plus 1, that's an int. Here's our while loop. Right? And then, okay, so this is one check, and we can just return the value. So I've got a return kind of in the middle. This is a little bit ugly. I'm feeling a little bit bad about it. But this is one case. Right? Sure. Do we have any other cases, though? What if that upper bound is the upper value? That could be a thing, right? So maybe we want to check for either of those conditions. So how about we do this one first? We'll say if the lower bound is equal to integer.min, integer min value, nope, min value, and the upper bound is equal to integer.max value. So if they said it can be anywhere from the lowest to the highest, then we don't really have to do any checking at all, right? If they said the lowest is the actual possible lowest and the max is the actual, we don't care. So we're just going to return, ask the user for an int, given the prompt. That's it, right? If you say the minimum is the absolute minimum and the max is the absolute max, we don't have to do any checking at all. I'm just going to ask the user for an int and go. Right? But if that's not the case, right? So when a return happens, the rest of the method never runs. So if this is not the case, I'm just going to check the next thing. If the lower bound is min, I know the upper bound can't be the max because this would have stopped. It would have gotten here and stopped. So if the lower bound is the min, we're good to go here. Then we can also check if the upper bound is the max value. So maybe you do have a lower bound, but your upper bound is the max value. Our loop needs to be this one. Or lower bound minus 1. And then as long as we're less than the lower bound, ask them for a number. Return. If that's not the case, then great, we'll do the thing we did before. So I've got a couple returns in here. It's going to be a little bit funny here. You could do if, else ifs here, and then just return a single value at the very end, if you prefer. I think these being inside of like, here's the if check, here's the if check, here's the if check, this is essentially the else. I think it's clear enough that I'll go back on that. It's kind of ugly to have a return in the middle, because you kind of see where they belong. Again, it's just a style preference. Not right or wrong, just a style preference. But do you follow how this is checking? Okay, did you give me the absolute min or absolute max? And where you have three different cases. Either they're both min-max, one is the max, one is the min, or I have something in between, and you need to be in between completely. So our loop here then does all that same thing. So it's a bit of a mess, right? We've got 100-something lines of code already. A lot of them are spaces, because it's nice to have spaces in between here. But sure. How you folks feeling? Do some validation. Got a thumbs up? No one online is around, that's okay. Cool. So we've done some validation. Let's see. So the book goes through it, then they do their future value validation. They kind of tie it all together. They've been building out this app. It's like, are you guys actually reading the book? All right, cool. I'm sorry? The Gaddis book? Okay.
I have both of them. Yeah, because I bought one from last semester, and then I was like, oh, cool, I should get that book.
Sorry. Hopefully, moving forward, the cheaper one works out better. Is it like leaps and bounds better? Like if you've read both?
Yeah, I explained it.
Okay.
And then it introduced the term, and then it would repeatedly give you, like, it wasn't just here's the introduction, and then you just assumed you learned it, and so
Okay.
like it would repeat that for me, which helped me.
Okay, some more repetition.
It's repetitive.
Yeah.
Which
Okay.
can be felt annoying to some people, but
No, that's good feedback. So we're trying out the book. I'm hoping it works well and we keep it because it's cheaper. There's actually a free book online that I tried to pitch, but my colleagues said no, for reasons. It had less than this book has, so it was a little bit slimmer. So like you didn't get quite as many examples, and they're like, well, students actually read the book, and I said most of them don't. Just be honest from the feedback I get from people. Most people tend to not read the book. Mhm.
coding, like examples, I guess.
Cool.
But like this, it relies on you to go in and download their stuff and use all their examples and go from there. And I like that. The other one just like kind of is a good practice.
Mm-hmm. Yeah, the definitely practice is definitely good. Apollo said they just skimmed through looking for the differences from C or C++. Yeah, if you've done another language, like any intro to programming book is going to be really boring because it's all the same concepts just done in a different language. So, all right. Yeah, so that's the intro to methods. We're going to keep on using them here on out. You don't need to use them at all for Project 2 because we hadn't talked about them yet when it was assigned. If you want to, go for it. I know a couple of people have already turned it in, fine. Like there's no requirement to use methods at all, but if you want to try it, now that you know how they work, you can go for it. It might actually save you a bit of time on some of the prompts and things that we do. Like it's the same thing except for this string. Right? If the only thing that's different is the string value, that could be an argument to a method. Right? So let's have just a bit of fun here real quick then. And let's look at, I'm going to start a Project 2 shell. This is for the evening shell. So I'm going to write just the main method and just pretend there's methods that exist. Does that sound like fun? And then, you can fill in the method part afterwards, right? So let me pull that up here. Let me grab it. I guess I can do it on this screen, right? Take a look at assignments. Edit this one. I gotta grade your project 1. I'm sorry, I forgot to do that this week. I'll start working on that tonight. It's still within a week, right? A week when it was due? Just barely? Just barely? All right, our bad text adventure text game. I can make this. All right, so if we are just going to have a main method that calls a bunch of other methods, right? So here's the output the story intro. So the first thing main would do then is, display story intro. Probably a void method, right? Probably doesn't need to actually do anything yet. Sure. Now, it gives you a little hint here. It will make methods for you, which is kind of nice. It's not always all that useful or helpful. Like sometimes it picks the wrong thing. So sometimes it's nice, but it's not that hard to print out like static void display story intro.
Depending on the description your dog has to be set to protect random items.
Yeah.
Either way, like, say you want to do display the story intro, and then you want to clear the console, like, and then say, like, what you want to make, like, kind of how the game was.
There,
If you do that.
yeah, let's see, Java clear console command. This? That's my first guess. That's the first hit. How to clear console. If you print that, it ought to do it. Huh. I've never done that before. No one's ever asked me, though. That's interesting. We could try it and see later, but... I mean, if you want to make it pretty, go for it. Let's do the function first, and then we can do the pretty stuff. I like that idea, though. All right, so we display the story intro. Great. Oh my goodness, where'd all my windows go? There it goes. And then ask what they want to do. So we'll have like some sort of choice. So a string for choice equals get user's choice. Or action, maybe, I don't know, action. Command, I don't know, user's command. Whatever you want to call it, right? So this one's probably going to return a value, right? If we're going to save it. So public static, it's not a void if it returns something. It's probably going to return a type of, what type here? Is it an integer? A string, right? So string get user's command. Now, it's going to be upset until I return something. So for now, I'm just going to put in return nothing, like an empty string to make the red go away. Obviously, that's not what you want, but it at least makes the red go away, right? Otherwise, it's just all red, and it just is really obnoxious to look at with all the red. Okay, cool. And then we need to see if it's a valid action, right? So check. So check if is valid command given the choice. This should probably do something, right? We'll figure out what it does later. The public static, it maybe returns something, maybe doesn't return something. You know, it's totally up to you. And given a string for choice. So this one then wants an argument, right? If you tell me what the choice is, I can go check and see if it's valid or not. Sorry, that's kind of way down low. Right, and we can see, hey, did it match one of my directions? Did it match one of my actions? Checking the health thing has to happen at some point in here too, right? So like the directions aren't valid if your health is 1, right? So it's not valid at that point. Sure. You know, maybe we could make this, how about a Boolean, right? It could return a true or false. Yes, you can do this, or no, you can't. True, yes, you can. False, no, you can't.
Are you allowed to have them die?
Yeah, if you want. Yeah, but whatever's going to be more interesting for your story. So if you can, sorry, not Firefox. If you can kind of go through this rubric and like, hey, I did this, but maybe in a slightly separate way when you're doing your self-evaluation, just tell me that. And I'm fine with you going in a slightly different way. But if you're like, hey, it doesn't let them do anything, and as soon as they type a command, they die, you didn't get enough of it done, even though it might be fun or funny. Don't diss Terry.
You gotta give them at least 10 moves to get this in there. You gotta think that they could have made it harder.
Have you seen the one like Terry Crews? He died of dissing Terry, and Terry Crews kills you.
So like, what if I just have them like get things at once and then die?
Look, are you importing a reverse?
So we
That's other option.
you probably need a place to track their health. So 2 options for that. One, you pass it every time as an argument, or 2, remember how we had scanner as a class level variable? You can have a static int health starts off at a value. Public, right? Again, sure, it's not ideal. We'll figure it out next chapter, better ways to do this. But for now, public static int health. Now, I can use this health value everywhere else in every single method ever inside of this other curly braces. So that I can use that health value without having to pass it to, hey, is this a valid command? Here's my current health. Either way is okay. But, you know, this might be a little easier to work with that way. Sure. So if it's valid or not, how about one for display help? So, like, if it's valid, yes, we do it. So, sure, if check is valid choice, we do something here. If it's not valid, something else here, or like display the help maybe. Display help. Sure, and then we need a method for help. Like static void display help. Sorry. Yeah, or command list, sure. Oh, I guess we offered they would have to know help, or if you just want to give them the help just command list, either one's fine. Yeah, did I include a help command? Okay, so this is either it's the help command specifically, or if it doesn't match, you could give them this as help. Either one's okay. I guess this isn't all right. Maybe we don't do that then. Maybe that just is somewhere else for displaying help. Sure. Any way you want to go about it, it's fine. So we got help. Sleep is an action, right? That's one of those actions that would do something, decreasing their health. Sure. If it's not valid, tell them they can't do that. And then a secret escape word, right? We need to get what that secret escape word is. Or no, we need to set that, right? So we'll have some secret escape word, right? So the whole thing is in a while loop. We'll have our string for secret escape word. escape word, something. I don't know, again, whatever you want to set it to. And the whole thing is while their choice is not that, equals ignore case. Oops, that should probably be first then, right? Equals ignore case, the secret escape word. And while it does not equal that, right, we're in this loop here. And then we should probably get their command again. But probably at the end, right, of the loop. Or at the beginning and then do all the checks. Either way should be fine. But this way we get it once. And again, some method, so like, it's sure it's a repeated line of code, but not even really all that much repeated. So that is one nicer thing about having all your prompts be in things like this as a method. And it's not the secret escape word, great. Count the number of turns they spend in the terrible game. So at some point in here, you need to count number of turns, but that only counts if it's valid, that sort of thing, right? So you probably have a counter in here somewhere. But this is kind of the gist of it, right? Here's a method, here's a method, here's a method. There's a lot that happens inside of this valid command, and like if it is valid, do the command. A lot that happens there. Sure. Now, this method could also give them the output, right? It doesn't necessarily have to just return a true or false. It could also print things and then return a true or false. Totally up to you, right? If you're already checking, hey, does it equal this command, or does it equal this command, or does it equal this command, or does it equal this command? You could probably just spit that out, right? Whatever that story bit is right inside there, instead of having another one that says, is this command's print story, if it's this command print story. Do yourself a favor. You don't have to do, like, don't have to repeat it twice, essentially. How's that feel? So, like, without any actual methods being done, you kind of see what's happening in here in our crappy adventure game. Right? And obviously, it's not done. A lot more work has to happen, but just from the main method, with nothing else being there, we kind of have a shell of what's happening. So our methods have nice names, right? We're never using story intro a second time, but sure, it's nice. We have it here, right? And that's the name of what's happening. So the advantage is to methods, right? It puts a name to what's happening for that block of code. It encourages code reuse, right? Especially with arguments. If the only thing that changes is like the argument or this parameter that's different, whether or not it's a string I'm acting on or some integers that I'm acting on, if I'm doing the same steps here, I can reuse the code, right? And then another fun term here I'm quite fond of is functional decomposition. It takes a big problem and it breaks it down, decomposes it into smaller and smaller and smaller problems, right? Your first read through this is like, oh, this is a bunch of stuff. But if you take a step, and break it down, and take a step and break it down, and take a step and break it down, like, is writing the intro story easy enough? Is getting a user command easy enough? Is checking is valid? Okay, that's still a big one, but sure, like, we're going to break it down into smaller and smaller and smaller bits. So I don't need to do the whole thing all at once. I can break it down into smaller pieces and solve a small problem, and solve the next small problem, and solve the next small problem, solve the next small problem. So it's a little easier to get less overwhelmed when you solve things by breaking it down into methods. Okay, do this step, do this step, do this step. So we get a lot of gains from using methods. Again, totally would function the exact same way if everything was in main. You don't need to have the method, right? It doesn't make it any easier to solve necessarily. Maybe with some of this repetition it might, but it's just a tool that we're using now, right? It goes in our toolkit. We're adding as we're building up, learning all these things we can do in Java to solve problems. That's actually it for the methods chapter. It's a lot. Definitely will need some practice. So if you haven't yet, I'd encourage you to try for Project 2. Do this method style. You're welcome to use this shell. Just drop a note like, got it from here, right? Put a URL in, and we're fine. Right? If you don't do it, again, I'm not too concerned for this one, but it's a good habit to get into. Like, hey, I found some code. Here's where I got it from. Here's a starter shell, right? We're great. So let me commit all this out to GitHub here. I think this is 1500. There we go. This is methods and project 2 shell. All right, cool. So that'll be all out on github.com for you if you're curious. I think we hit the highlights of this. Again, there's a little more to it here. but this is kind of get your ideas flowing of how you can use methods to help you solve these problems. From here on out, probably everything we do will be in methods. I mean, I'll probably still like write some quick little examples in main, but the idea that we're going to use methods here on out to put names to what's happening is fantastic. We'll try and be in the habit of that as we go. Oh, this one's upset because I didn't return a Boolean. Sure. Return false. I don't know. Why not? Okay. The red error. All right. Other thoughts, questions, concerns? It's a little earlier than I thought it would be. Again, I'm aiming for about 2 hours of me talking, and then you've got the other hour 45 for you folks to practice, try things, work on the projects while I'm here and I can walk around. If you're fried, that's fine. We can meet during office hours, Tuesday, Thursday mornings, Wednesday afternoons, or by appointment. And then I did put now in D2L, there's the group tutor sessions, Tuesday and Thursday from 1 to 2. Those are optional. Someone had asked, yes, totally optional. If you do attend them, I get the attendance reports from our supplemental instructor, Tim, and it'll be worth a bonus point on the weekly quizzes. So tonight I'll post the quiz. You do have the chapter 4? I can't even remember chapter numbers anymore. Quiz coming up. Yeah, the chapter 4 quiz to do tonight, 11:59 p.m. Hopefully those are free points for you. Again, if the short answer gets marked wrong, just let me know. I'm happy to go in and fix that for you. You should be able to see the answers after the due date. So, midnight tonight, the answers will open up. You can tell me if it graded you wrong on any of them. Happy to go in and look. Okay? Cool. So we'll keep up that flow. We've got next week, we'll start with the solution to project 2. I'll just open up the shell and finish it, essentially, because we already have the shell of it there. And then we'll get into the next chapter, and then we'll talk about the next project. So every 2 weeks, we're going to keep up project. So you keep practicing things until we hit the midterm, which is a little late in the semester. There's an extra week there, one last individual project, then our final project, end of November, all of December. Again, I'd like this to be in pairs. I know we're still kind of in the middle of a pandemic, so if you'd rather not work with somebody closely, that's fine, I get it, if you can do it individually. So up to you folks. And then we are off for Thanksgiving the whole week. The college is closed, which is cool, instead of just like a Wednesday, Thursday. You don't have to start on it at all if you don't want to. And then we've got more Java FX stuff. Again, there'll be a slightly shorter week, lots of time to work in class afterwards. 12/7, just final project time. I've got nothing else planned to talk about. So it'll be just for you folks to work on the project. If you want to come in, if you want to stay home, that's fine. You can still meet over Discord and whatnot. And then 12/14, we're going to do presentations. So instead of Twitch, we'll be on Zoom, so anyone remote can present. We'll take turns showing our little final game here, and hopefully it'll be a lot of fun. And that's the goal. So we are a third of the way through the semester now, believe it or not. 5 weeks in, a third of the way done, and we are cruising. So like the first third, the second third are real heavy. The last third is just this Java FX stuff, and then lots of work time. So essentially halfway through the content already, believe it or not. So it's just flying by. So keep up, keep reading, keep practicing. Let me know how I can help. Again, the goal, I would love if everyone got 100%. I'd be super excited if everyone got 100%. I don't like to fail people. I don't even like to give C's out. They feel sad. But if that's all you need for transfer credit, great. If that's all you need, and that's you don't have the time and energy to put it in to get 100% of everything, that's fine too. No issues there. But let me know what I can do to help you. That's kind of why they pay me. So otherwise, you could just watch the YouTube videos or something. All right, folks. Take care. If you're online and want to chat, I'll be on Discord, hanging out, working with the rest of the class, walking around. So just give me a few minutes if you ping me.